Okay, example 4. Polynomial function of least degree with integral coefficients whose zeros include 4 and 4 minus I. So it seems very confusing. Basically, we're just putting words here. So let me grab a color here. Let's grab blue. So 4 is one of our roots. So that means x minus 4 is a factor. And you know if 4 minus I is one root, then 4 plus I is the other root. And let me switch. So I'm going to write this factor as x minus 4 minus I, and then x minus 4 plus I. Let me switch these to brackets. So this is how these zeros turn into factors. And we already know how to take the 4 and change it into x minus 4. So notice that both of them have a minus sign. And then we just move the factor straight down. Just like we did with the 4, we have the x minus and then the 0. We've got the x minus and then the 0, the x minus and then the 0. So then we're ready to FOIL this back together again. So this gets kind of complex. I'm just going to leave this first part alone. So I'm going to bring it down. I don't do anything with it to begin with because this other side I'm going to play with for a bit. So I'm going to rearrange this. Hopefully you're okay with this. This would become x minus, I'm going to distribute this negative sign here, 4 plus I. And this one's going to become x minus 4 minus I, which really hasn't done too much. Again, I'm just distributing that negative sign in here, but makes it go towards something I'm better to work with. And then I'm going to write it a little bit clearer for you. I'm going to take this x minus 4 and write it by itself. Write the x minus 4 again by itself. Okay, then I'm ready to FOIL this back together. And you should notice that this is the same thing like if I had x minus 2 times x plus 2. Then whenever I FOIL that back together, I would end up with x squared minus 4, right? The square of the first one minus the square of the second one, because our middle terms would drop out. This is the same thing. We've got our plus and our minus. The first terms are the same, and the last terms are the same. So whenever we FOIL them together, our middle terms are going to drop out. Just our middle terms are a little bit weird. So I'm going to make this as an x minus 4 squared minus I squared. Doing the same thing that I did up here. Okay, then I'm ready to actually FOIL that. Let me extend my page a little bit. So FOILing x minus 4, remember to write it again. And do your first outers, inners last. When you do that, you end up with x squared minus 4x, and then minus 4x plus 16. And then I squared is a negative 1, so that's minus a negative 1 when I take care of my I squared. Then I'm ready to collect my like terms. So that's going to be x squared minus 8x plus 17. And then I'm ready to put back on my x minus 4 out front. Yep, this is long and forever. Keep going now. We're going to distribute the x, and then we'll distribute the negative 4. So distributing the negative, or distributing the x here, that becomes x cubed minus 8x squared plus 17x. Then if I distribute my negative 4, that becomes negative 4x squared plus 32x minus, and 4 times 17. 8 down here, the 2 is a 68. Final step, combine all your like terms. And I've made a mistake. Let me fix that mistake. That should be a cube, because x times x squared is x cubed. There we go. So now I'm ready to put it all back together. So I have an x cubed, and then I've got minus 12x squared plus 49x minus 68. And all of that is going to be equal to my f of x. That's my final answer. Oh, again, I forgot to make that a cube. I seem to be having trouble with that. That is a cube. So it's x cubed minus 12x squared plus 49x minus 68 is the final answer, because you're working backwards and trying to figure out what the original function was from those roots. And remember, anytime you have one of those, you actually have two of those. So complex roots come in pairs of two.